Okay, moving right along. Tony, can you share your screen, please, and present for Mobius? And unmute yourself. Tony, you're going to have to unmute yourself.
Sorry, the toolbar disappeared for a second.
We got you.
Great. So can you all hear me now?
Mm-hmm.
Excellent. So we've all heard about plastic drinking straws, the usual suspect for our society's new favorite villain, plastic waste. They're in our landfills, in our oceans, and in turtles' noses. You may see this and think that the future is garbage, and I do too, but for a good reason that I'll get to. But there's another plastic waste source that's 10 times as large as straws that most of you have seen, but very few people talk about. This hidden stream of single-use plastic, flower pots. These little black plastic containers that are temporary homes for your tulips, your tomatoes, and trees before they get transplanted into your front yards, farms, and forests. There's over 5 billion of these single-use plastic containers used every year, and the majority of them are landfilled or incinerated because black plastics are not easily recyclable. Wouldn't it be great if you could plant the entire pot in the soil where it would degrade and feed the plant at the same time? My name is Tony Bova, and I'm the CEO and Chief Beard at Mobius. We're a public benefit corporation from Knoxville, Tennessee, and our company makes biodegradable plastics that can be used to create products like flower pots. Best of all, we use organic waste instead of petroleum, and I really do think that the future is garbage. Our first technology uses lignin, which is a natural material found in trees to create these plastics. Lignin is the primary byproduct and waste stream of the paper industry, where they landfill or burn over 100 million tons of it each year. At Mobius, we combine lignin with some chemistry. This chemistry happens in standard plastic manufacturing equipment where we create bioplastic pellets. These pellets are then compatible with the exact same equipment, molds, and tooling that manufacturers use today to create plastic products like flower pots. There are lots of companies out there that can create our plastic pellets and create products from them, so we don't need to own ourselves any manufacturing equipment, enabling a distributed manufacturing model. To date, we've built a supporting supply chain in both the US and in Europe. Companies like Ingevity and UPM can supply us with lignin. Summit Plastic and M Plastics can manufacture containers from our bioplastic pellets. And retailers like Lowe's in the US and Kingfisher in Europe are partnering with us to help pilot these materials for the over 150 million plants that they sell each year. Within agriculture, our bioplastics can go beyond flower pots to create more products like controlled heat and even plastic mulch films, all helping growers be more productive while reducing their plastic waste footprint. The market for these flower pots is over $3 billion, which is part of a much larger $17 billion market for single-use plastics all throughout agriculture that also includes products like plastic mulch film and slow-release fertilizer coatings. Beyond that, there's a $400 billion market of single-use plastics for us to explore, but I want to tell you today that we're more than a lignin bioplastics company. Our goal as a company is to create chemicals and materials for the $767 billion specialty chemicals market, all starting from organic waste. At Mobius, our mission is to create a world where there's wonder in waste. We're doing that by building the world's first distributed waste refinery. So imagine a world where all organic waste, from banana peels to cooking oil, is used to create biodegradable trash bags and laundry detergent bottles, or even consumer products like hand soaps and cosmetics. By combining chemistry, biology, and engineering, this is what we can do. Our business model is to work with existing manufacturers that purchase these chemicals and materials to make their products. Nearly every good we buy today that's not food is made from these chemicals and materials. Manufacturers can buy from us, and we can make those biochemicals and materials from organic waste streams that we can buy or remove for free. And what do I mean when I say organic waste? This is the leftover material from food, forestry, and agricultural practices, from tree bark to banana peels. All of this waste is made of 4 primary components: fat, sugar, protein, and lignin. And at Mobius, we're building a massive database to track the composition of these waste streams at an industrial scale. Imagine a future where we have a waste nutrition label that lets manufacturers and companies like us know how much good stuff is locked in that waste. Our business model allows us to build more technologies that can upcycle these waste streams and deploy these technologies on site where the waste is generated, eliminating costly transportation and enabling a distributed model. But lignin isn't the end of our story. We recently received a grant from Kroger for $100,000 to convert waste cooking oil from the food industry and to upcycle it into new biodegradable chemicals and materials using a combination of synthetic biology and thermochemistry. Now, you might be thinking that we're just a bunch of nerdy scientists, and you're right. But we've also built a reputation for applying science and entrepreneurship together to solve real problems in the world. I invented and recently submitted a patent for this first technology during my PhD. My co-founder Jeff's master's work was converting wastewater into valuable chemicals and materials using biological systems. Jeff and I have been great friends and working together on regenerative entrepreneurship for over the last 8 years. And the rest of our team of scientists, engineers, MBAs, and advisors are experts in their fields and working with us to create circular materials and chemicals for the future. When we started this company in 2016, we were just 2 beards and a pitch deck. We bootstrapped since then to raise over $2.2 million from competitions, grants, and investors. In the last 12 months, we ran a pilot to produce 2,000 pounds of this first bioplastic on commercial scale production equipment. We created first prototypes and have built more partnerships to bring our biomaterials to market. We've recently signed 2 paid pilot agreements, have an offer to license this first technology in Europe, and have a strong pipeline of partners throughout agriculture interested in everything from flowerpots to controllable seed coatings and waste-based fertilizers. There's over 1 billion tons of organic waste produced every year from food, forestry, and agriculture. There's more than enough carbon locked in all of this waste to replace all of the specialty chemicals currently made today from petroleum. Our vision for the future is that a distributed waste refinery model will be a key part of the global circular economy, helping Mobius create a world where there's wonder in waste. I'd like to part with an unofficial quote from our mentor and resident waste expert, Oscar the Grouch. Just because you're trash doesn't mean you can't do great things. It's called garbage can, not garbage cannot. Thank you.
Thanks, Tony. I'm going to open up the questions again. This time, Arye, do you have any questions right now?
Absolutely. Yeah, great work, Tony. Thank you for the presentation.
Thanks.
So I'd just like to distill down, you guys are doing a ton of stuff. So I would like to kind of distill down on, what your first sort of product is or what your first project is. And if it's those flower pots, then I'd like to sort of drill down on that a little bit more.
Sure, yeah. So the most mature of the technologies that we're working on, and the first one we're going to market with specifically is the pelletized bioplastics. Flowerpots is the most advanced application that we have in our pipeline for those.
Okay, and those are made from byproducts from paper mills?
Yep, so the bioplastic itself is made of lignin, which is a byproduct from the paper mill, and then other types of bioplastics or biopolymers that are made from different sources, food waste, microbes, those sorts of things. And our product would be the raw material that companies can use to make these bioplastic pots.
Okay, got it. So how challenging is it going to be to bring the cost down of those that product? Because obviously that's one of the challenges is you're going up against a commodity product that's extremely cheap.
Sure, no, that's a great question. The 2 primary ways that we're doing this, one is by using waste as a feedstock. We can get these waste streams for relatively low cost, and in the future are hoping to be able to have partnerships with the waste producer. We can effectively on site next door to kind of limit the costs of transporting and have even an in-kind model to use those. The other angle that we have is this particular technology, there's not a level of energy and water intensity that you often see with other bioplastic or bio production technologies. We're not using fermentation or any large things. This all happens in a thermochemical process using the exact same equipment that companies who make plastic pellets today do now. So that allows us to be really efficient and scale without needing a lot of expensive infrastructure, which is different than what some of the other bioplastics in the market need to do today.
Okay, yeah. And what about kind of stability and comparability to petroleum-based plastics? That's one of the big challenges in the bioplastic field, is that some of this stuff can degrade or fall apart or whatever. So how do you look at that issue?
Absolutely. That's a wonderful question. One of the benefits of the technology that we have is by understanding the type of lignin that we're using, whether we're using it from a different tree or plant species, and then the way that we can tune our formulation, we can tune the degradation timelines for these materials. And depending on those applications, we may want to see things that are faster degrading or slower degrading, which is something that some of the other bioplastics in the market can't right now. At the same time, we're also optimizing for mechanical properties for specific applications. So something like a flower pot doesn't necessarily need to be the same type of plastic you might use in an automotive application, which is why the agricultural sector is a really good entry market for us, because we can be focused on what that specific market needs versus some large engineered product that's not really in our wheelhouse.
Mimi, do you have any questions?
So, you talk about sourcing these organic matters. How do you source it? Because I think that's, your primary, how do you source the organic materials?
That's a great question. Yeah. So our model is to be able to work with the companies that are processing these at an industrial scale. So paper companies, for example, are producing on the scale of 100 million tons of lignin per year. If we were to park up next to a paper company like the one that we were talking about that's in Finland, or there's another one here not too far away from us in North Carolina, they're producing anywhere from 75 to 150 tons of this raw material per day. They process it into a dry powder for this particular example, and that makes it really easy to transport. For future technologies, say if it's waste cooking oil or something like a tomato peel waste from another company to turn into a biomaterial, we would do the same thing. We would work with a large company like a Kraft Heinz of sorts, to where we could have a contract to be able to take large amounts of that raw material in a single stream at a large scale. The goal is not to go rummaging through all of our trash cans at home.
Do you currently have any partnerships with any of these organizations at all?
We do, yeah. So we have partnerships with UPM in Europe, and then Ingevity, which is a company here in the US that's they're a spin out from one of the large multi-merger sets of paper companies. We've been working with them for a little over a year each, using their materials in a lot of the prototypes that we've made, and have talked about what the long-term scale-up looks like in terms of supply for those raw materials.
So talking about long-term scale up, when you scale up to larger manufacturers, how do you have plans for that? Do you have infrastructure in place? Because it sounds like you're gonna have to scale a lot. You're gonna have to source all of this material. How are you gonna do that? What are your plans for that?
That's a great question. So our plans are to work with companies that are already in the business of producing virgin plastic materials. In Tennessee, for example, just about an hour east of where our headquarters is, there's a company that produces compounded plastic materials that they sell to manufacturers. They've offered to be a contract manufacturer for us, and that's how we envision scaling up in the beginning part of our company, to work with facilities that already have the equipment, the staffing, and infrastructure, and working out either direct contract manufacturing agreement or a licensing arrangement where they could produce our materials using our formula and IP.
Okay, and just one last question, as a gardener myself. I think with bioplastics, you do have a lot of competition with the pulp paper pots. You know, what's the cost comparison to that? And what
That's a great question.
Going against them?
That's a great question. So one of the biggest reasons that we got into this particular sector was at the home gardener level, there are pulp and paper pots that may be easy for you to use. But on a commercial greenhouse scale, a lot of those materials can't withstand the physical requirements that happen in an automated greenhouse. The machines that automatically fill and move the pots around get crushed. If they get wet, they start to grow mold, and that's really bad for becoming a source of pathogens throughout that greenhouse. And those particular molded paper products are about the same price as a virgin plastic material, if not a small premium. So we feel that in the beginning, we should be able to be price competitive with the pulp products, but have that same physical plastic durability, like this little piece here, I don't know if you can see it, to be able to stand up in that automated greenhouse environment, the frequent watering without growing any sort of mold and being a source of pathogens like a paper container might be.
And Lucas, any questions?
Yeah, just a quick one, just about the team. Wanted to find out who, if anyone on the team had like more of a sales background. I see a lot of scientists, but I want to know who would be leading the charge on that.
Sure. So in the beginning, the majority of the business development, I could pull that slide back up, has just largely been myself. We do have a great team of advisors. So Lynn Youngs was a COO for a number of companies here in the greater Knoxville area. And Gary Robinson is an advisor for us that's been helping. He actually worked for a long time in the sales and development team at a company called Billard Korsnäs, which is a large pulp and paper company. He's been able to give us a lot of insights on how those types of B2B relationships in this biomaterial sector work. Once we get our technologies ready for launch, he's going to kind of helping out our proper sales team to bring these to market. But to date, it's been me.
Cool, yeah, appreciate it. Great presentation.
Thanks.
Thanks, Tony. If you could unshare your screen.